Hello everyone, and you're welcome to Postman Galaxy. My name is Adora and I'm very excited to be giving this talk to you today. So in today's talk, we're going to be talking about designing secure cloud applications. When it comes to the cloud, one of the things that we have seen, one of the things that are important, is that moving all our computing to the cloud has made computing easier in general for a lot of us because of the many benefits that come with the fact that we can now do our computing on the cloud. Less load, you don't need to install things on like local computers. You pay for actually what you use, you have on-demand self-service and all of these really nice things. But then at the end of the day, with all of these new benefits, because we are now able to access our applications over the internet, it means that our applications are public and other people can access them too. So we need to find ways to make sure that our applications are safe while they are being served over the internet. And I am going to be explaining what I mean with a very short video that can explain this in layman terms.
Hey there. I'm going to tell you a story about what happens when you do not protect public resources. This house has water supply in form of a bucket at the compound. This is a housemate who actually needs water. He gets some into his bowl and goes back inside. This second person, who happens not to be a housemate, comes to the public area where the water is and makes it unfit for everyone to use by washing her hands inside. This housemate happened to be walking in the direction of the water and accidentally kicked it. Now all the water is gone. Why did this happen? Because access to the water wasn't properly regulated. How do we fix this? Take the bucket away and keep it in a safe place. Secure the house to prevent outsiders walking by from tampering with resources only meant for housemates. Connect a tap so that housemates get water in a structured way. The end.
Just imagine the public water supply is your cloud application, right? The public thing that everyone's supposed to have access to. And the people in this video are divided into two buckets. People that should have access to the water, which is the housemates, and people that should not have access to the water, which is people that are not housemates. But because the resource wasn't secure, as we can see in this video, even people that were not supposed to have access to the water were able to, gain access and not do the right things with that resource. And now based on this, we can see that, human errors can happen when we don't properly secure our cloud applications. I mean, look at how the bucket of water was accidentally kicked away. In security and in cloud engineering terms, this could be that somebody has access to production when they're not supposed to have access to production, and as a result might mistakenly go and delete one resource in production that causes the system to fail when a customer tries to use it. I mean, when your cloud is also not very secure, this is how people actually gain access to cloud applications and do despicable things, because they had access in the first place because security wasn't properly done. Also, you might enter, legal or compliance issues with customers because somebody might want to sue you because they feel that their data, they don't feel that you are securing their data, or they feel that you're actually selling their data to other people. When the truth is, you might actually not be. It's just that you didn't write code in a way that makes your service secure, or you didn't put measures in place to secure your application a lot more, and because of that, things are happening. With all the things that I've said, in this talk, we're going to be going through 3 security patterns when you're trying to design your applications so that you can, optimize for security. And we're also going to be going through a few measures that you can take when writing code to help secure your applications even more. Before we go into any of that, I want to introduce myself first. My name is Adora and I am a software engineer at Microsoft Mixed Reality. I'm a tech content creator at Adora Hack. Adora Hack is a brand. It's also the shirt I'm wearing. It's a brand that I created, and I use that medium to share content on tech, career growth, and lifestyle. I write, and I also have a YouTube channel, I'm a co-founder of On Stack, which is a community where all our talks are focused on, hands-on workshops because we believe that many people learn by doing. I'm also on the advisory board for VRARA Nigeria, which is the Nigerian chapter of the VRARA Association. And as someone that is enthusiastic about mixed reality, I am trying to get everyone excited about that technology in this region and grow a community. That's one of the reasons why I'm also doing this. And I'm popularly known on Twitter as Adora Nwodo. If you want to reach out, feel free. I will be happy to have a conversation with you. So moving on, when you decide that you're going to build an application and you're going to have that application on the cloud, the first thing you need to think about is analyzing and understanding what your security requirements are, analyzing and understanding whether the application even needs to be secure in the first place. And this requires you having a security checklist. And some of the questions that you might ask yourself would be, will my application, contain sensitive data? Where and how is my application data stored? Will this application be available over the internet or publicly? How do I plan to verify my user's identity? Once sensitive tasks are performed in my application, does my application perform any risky software activities? When you ask yourself these questions, you'll be able to answer some of them, and that will determine, the type of things that you are supposed to be doing in the first place. So, for example, if your application contains sensitive customer data, you would want to think about a data protection method for your application. If you are going to have users maybe logging in and logging out of your apps, you want to think about a valid way to do authorization and authentication, as well. If your application is going to be performing risky software activities, like maybe users are going to upload something to the app and then you use that. Maybe, for example, you're supposed to upload an image and then you process that image. That's risky because somebody could upload a malware that could damage stuff and just rename it to be a JPEG, and that could damage things. So you need to find ways to protect yourself against malicious data in these types of cases. And looking at these 6 questions that I talked about in the previous slide, I broke it down into 2 buckets. So the first bucket is the data protection bucket, and the second bucket is the identity management bucket. And these 3 security patterns either belong to one of these buckets. So I'm going to be talking about the Gatekeeper pattern, which is under the data protection bucket. I'm going to be talking about the Federated Identity and Valet Key patterns, respectively, which are under the identity management bucket. So now let's talk about the Gatekeeper pattern, which is a data protection scenario. Applications functionality would usually be exposed, when they accept and process a client request. If the system is compromised and a malicious user gains access, all the sensitive data would be vulnerable, exposed, and possibly even lost. And let's look at how a gatekeeper helps us solve this problem. The benefits of using a gatekeeper is that a gatekeeper helps you, validate requests, it's limited risk, and it boosts security. Let's look at the gatekeeper. A gatekeeper is what the client communicates with. So in this diagram, as you can see, the gatekeeper exposes endpoints to a client. And when the client calls the endpoints that the gatekeeper exposes, the gatekeeper will validate and sanitize all the requests. And it only routes valid requests to the host. So you are sure that once any request is getting to a host, it is a valid request and it is a secure request. And then the host now has, secure access to the service and to your storage, so it's a lot safer. That's a concept diagram. A real life way that people can implement the gatekeeper pattern is by having, different roles, different modes in your system. And your gatekeeper role could be limited privilege mode, so it can't have access to everything. There's some actions that the gatekeeper role will not be able to perform. And then the user calls a public endpoint, and the public endpoint is what has, the gatekeeper role. And then the gatekeeper is able to successfully validate and sanitize the request. Once that validation is done, the gatekeeper calls the internal endpoint. And that endpoint, that component, that service, that thing would have a trusted role, which is in full privilege mode and can, access the service and the different resources, access storage, access things securely. So as opposed to, calling the host directly, you go through the gatekeeper, and that sanitizes and secures your request before you can get to the main host. The next thing is the Valet Key pattern, which is an identity management scenario. This pattern helps you securely control access to data by using a token that expires after a period of time. And this key or token can be used for authentication or authorization. I'm going to use an example. If you are writing code that requires you to gain access to, let's say, Azure Storage, for example, and you might want to use this Valet Key pattern because you don't want the user to have endless access to Azure Storage. So you use this Valet Key pattern, to give the user some kind of SaaS token, and they can use that token to access the storage account, do what they have to do, and then at some point the storage is revoked. So this diagram explains this, and what happens is that the user first of all requests a resource, and then the application validates the request and generates a token and returns that token back to the user, and now the user can access a resource with that token. Let's look at this code example here. I got this code example from the Microsoft website. So what this source code is doing is returning a SaaS token to a user so that they can, access Azure Storage with that token. And this token is only valid for 10 minutes. So what happens is there's a private method called get shared access reference for upload, so that a user can upload data or content to the storage account. And what this method returns is a storage entity SaaS. So you create your blob using the blob service client, you get your storage shared key credential, you create a blob SaaS builder, pass all the information that you need into that blob SaaS builder, set your permissions. You want to have write permissions and you want your users access to this blob to expire after 10 minutes. So you set the policy and you create the SaaS token and return that token to the user. So now the user has that token and they can access the storage account, upload whatever file that needs to be uploaded, and after 10 minutes, the permissions get revoked and then they have to re-request again. This helps you manage how long someone has access to your resources for, so that you don't give them endless access and unspeakable things do not happen. The third thing is the Federated Identity pattern, which is also under the identity management scenario. So this helps you separate user authentication from application source code, and you can now delegate authentication to an external provider. And this works in sort of like a claims-based way where you can have tokens and then, add different claims and then use those claims to identify the certain user and privileges that, this user should have on whatever part of the system that you are in. And how this works is that the service, decides that, I'm going to be using an identity provider, I'm going to be using some kind of STS. And a user tries to, authenticate and requests a token. The user gets the STS token back, and the user presents this STS token to the service and, can get authenticated. The user's identity can get validated and the user can go ahead to do things. This pattern is good for single enterprise sign-on, multiple partners, and for SaaS application. I talked about it being claims-based, so you could have, different claims to help identify the user, what tenants the user belongs to, which is what organization the user belongs to. So if you are building apps for a particular tenant and you have disabled cross-tenant access, it's like, if you don't belong to my tenant and you try to do this thing, I'm going to kick you out, essentially. And this helps you properly manage claims and do things so that you can focus mainly on the core of your application and not on authentication. So now that I've talked about these things, I also want to state a few ways that you can enforce security. Using multi-factor authentication is very important. Nowadays, one password is not enough. Also, depending on the kind of application you're building. Your multi-factor authentication could be that you are using a third-party authentication app, you are sending OTP, or you are calling the user's phone and giving them which is still a way to do OTP anyway, calling them, giving them a code and having them type the code somewhere, or even as a security question, because sometimes people can try random multiple passwords, and once they have guessed the correct password, if you had multi-factor authentication, then they have to go and start guessing the code as well. And I mean, it's a matter of time before the account gets locked because it flags that there's a security problem. Consider implementing JIT as well. I talked about this, earlier on, so that you can regulate access to resources. You shouldn't just be having people gain access to your production environment randomly, right? You should implement JIT so that if somebody needs to do something on production, they request JIT access, they gain access, they do the thing, and then the access is revoked so that the entire team is able to manage who and who has access to things, and people just don't go and mistakenly start, deleting things because they thought it was a different environment or they were actually on prod or whatever reason. You should also use stable authentication and authorization platforms. I've talked about the Federated Identity pattern. Use stable auth platforms as opposed to writing it yourself, because some of these platforms have existed for years. They've had multiple attacks, they've mitigated it, they've learned from their experiences, and they've worked on making their authentication and authorization a lot more secure. So as opposed to reinventing the wheel and doing the same thing from scratch, you can take on some of these platforms and do that. Also, require re-authentication when you are doing sensitive actions like financial transactions, like transferring money. Even if the person is already logged into the app, right before they transfer money out of the app, you can ask for some kind of 6-digit PIN, 4-digit PIN, or a password or a security question, so that you are sure that it's this person that has access to this information that is performing this action essentially. Learn to reduce your attack surface as well. If you have a large attack surface, it makes it easy for attackers to gain access to your application, because if, for example, there's a VM that is somewhere that you are not using, remove it, because if you leave it there, they could try that VM and use that VM to gain access. And if they were unsuccessful, they could try another way and just keep hitting different points on that attack surface till they are able to, get in. But if you're smaller, then the probability that they would have been able to get in by hitting different points would be minimized. Also, properly handle errors and exceptions. This doesn't really help with security, but this helps with monitoring your application, so that if for whatever reason the application goes down, either because of a security problem or because of a bug or because of an infrastructure problem or whatever, you will be able to debug properly and your service will be back up in no time. Also, encrypt sensitive data. If data is very sensitive, you should store secrets in something like a secrets manager. You shouldn't be hard coding values. Your environment variables that are very sensitive should be referenced from a secrets manager. Learn to keep sensitive data encrypted, and also if you're going to be transferring data from one place to another, learn to keep all this data encrypted, just so that you can avoid attackers hijacking that data and doing unspeakable things with it. Implement fail-safe measures as well, so that if your application fails, it fails gracefully, and somebody that wants to retry can go ahead and retry that operation without the whole system scattering just because an action failed. Consider threat modeling. I believe that threat modeling is something that is very important, because it sort of helps you in that design process analyze possible threats that could happen in your system and think about ways to mitigate these threats. Think about ways to prevent these things from ordinarily happening if they would have happened. I'm going to be talking about Stride. If spoofing attacks are a possible threat, that's an authentication problem, and you might want to enforce HTTPS connections. If people tampering with data is a possible threat, that's an integrity problem, and you might want to use data protection methods, and you might want to use valid, SSL and TLS certificates wherever. If repudiation is a possible threat, then non-repudiation is the security property, and you might want to enable proper monitoring. If information disclosure is the threat, then that's a confidentiality problem, which I believe is very important. So you might want to properly find a way to protect data, encrypt sensitive data, and do things to make your data safe. If denial of service is the threat, then availability is the problem. And like I said before, monitoring properly would help, so that if the service is down, you can see it in your logs and you can see exactly what happened, why it failed, and you can quickly go and fix it so that it is back up. If elevation of privilege is the threat, then that is an authorization problem, and you should use secure identity management as a way to reduce the chances of that happening in your application. It's also important to use secure libraries. If you're going to be using open source libraries, make sure that these libraries are libraries that are actively maintained. And if you're going to be contributing to those libraries, then that would be great as well. Update your dependencies to prevent vulnerability issues. And I've talked about this before, avoid hard coding. Always reference secrets from a secrets manager. If you want to learn more about, securing your cloud applications, you can check out these links on the screen. I think these are really helpful resources that can help you get, at least a few steps closer to understanding cloud security and being able to properly secure your applications. Thank you so much again for joining this talk. Like I said, I'm really happy and excited to be giving this talk. I hope you enjoyed this talk, and I also hope you enjoy other talks at Postman Galaxy. Bye.